Okay, let's take a look at these problems. And first one we'll take a look at is number 2. So we got 200.325 degrees. And it says convert the angles into DMS system, degrees, minutes, seconds. Round each of your answers to the nearest second. Okay, now what this means, actually making my calculator go on here. Okay, this is equivalent to 200 degrees plus 0.325 degrees. Now the degrees is fine, right there, but we want to convert this to minutes. And just to show you why I'm going to do what I'm going to do, if I were to put this in fraction form, put it over 1, I could use dimensional analysis, where I'd put the degrees down here, and I'd put minutes up here. Well, we know there's 60 minutes in 1 degree. So this would become 200 degrees plus, now these degree marks would cancel, like that. And then we'd have 0.325 times 60. 0.325 times 60. And that would give us 19.5. So this becomes 19.5 minutes. Then we'd have 200 degrees plus, and I can split this up. I can put 19 minutes plus 0.5 minutes. So we'll have 200 degrees plus 19 minutes plus, and if I put that as 0.5 minutes over 1, then I can use dimensional analysis to change that to seconds. Minutes is up here, so minutes has to be down here. Then I put seconds up here. Well, there's 60 seconds in 1 minute. So just like before, the minute mark should cancel there. And I'd have 200 degrees plus 19 minutes plus 0.5, which is 1/2 times 60, would give us 30 seconds. So we'd have 200 degrees, 19 minutes, and 30 seconds. Now, I think there's some way to do this in your calculator. Famous last words. Let me see if I can figure it out. Okay, I want to make sure I'm in degrees. Okay, so change that to degrees. And we got 200.325. And I want to convert that. There's an angle. Let's go see what's underneath that menu option. So we'll do second apps, go into the angle. And number 4, I believe, changes it to degrees, minutes, seconds. So if I choose that, then I get 200 degrees and 19 minutes and 30 seconds. Now that's not available on every calculator, but that's how you do it on this one. So let me clear that off. We'll take a look at the next problem. Okay, number 7. We got 502 degrees and 35 minutes. And this one will convert the angle in decimal degrees, round each of the answers to 3 decimal places. Well, this is equivalent to 502 degrees plus 35 minutes. And again, if we use dimensional analysis, I'll put the 35 minutes over 1 to create a fraction. And dimensional analysis is whatever unit measure is here has to be down here. So I put minutes down there. And then this would be degrees. Well, we know 1 degree is equal to 60 minutes. So to do the conversion, of course, those minutes symbols cancel. Looks like I'm going to divide by 60. So we got 502 degrees plus 35 over 60 degrees. So 502 plus 35 over 60 . Okay, I think it's 3 decimal places. 502.583 degrees. Let me double check that. Round each of the answers 3 decimal places. Yeah. So that would be our answer. Let's look at number 14. 14 says 5 pi over 6. Graph the oriented angle in standard position, classify each angle according to where its terminal side lies, and then give 2 coterminal angles, one of which is positive and the other one negative. Okay, 5 pi over 6. Here's 0. Clear over here is pi, or it's, let's try it again. It's 6 pi over 6. Okay, so it looks like then, I'm splitting this up into thirds as well as I can do it. This one would be pi over 6. This is 2 pi over 6. 3 pi over 6. This would be 4 pi over 6, and this one would be 5 pi over 6. Now, I know some of these simplify. 2 pi over 6 is pi over 3, but we see approximately where 5 pi over 6 is. It's right here. So this would represent your angle. Now it's quadrant two angle. I think they're asking you what kind of angle it is based upon that. And then they want a coterminal. Coterminal means you go all the way around the unit circle and you're back to where you started. And you could go clockwise or counterclockwise. So we could start out with 5 pi over 6. And we could add 2 pi. Or we could start out with 5 pi over 6 and we could subtract 2 pi. Now this is a mixed number form here. If you ignore the pi's, and you got 2 times 6 is 12, plus 5 is 17, we're going to have 17 pi over 6. Again, I took this number that's before the pi, the 2, multiplied it times the 6. 2 times 6 is 12, plus 5 is 17. Now down here, I'll take negative 2 times 6 is negative 12, plus 5 is, hasn't been that hard of a day, negative 7 pi over 6. Double check that. 12, yeah, negative 7 pi over 6. So this would be our positive, and this would be our negative coterminal. And looks like that's all they're asking for there. Okay, so next one is 31. What's 31 say? Convert the angle from degree measure into radian. So 31 is 135. Let me clear this off. Okay, so we got 135 degrees. Convert the angle from degree measure into radian, give an exact value. Okay. I'll again use dimensional analysis. So I'll put over 1. Now we have degree up here, so we put degree down here. Now I'm going to put radian here just to really emphasize it. We're looking for some kind of connection between degree and radian. Well, we know 180 degrees is equal to 1 radian. Or pi. That didn't sound right. If I looked on the unit circle, clear over here at 180 degrees, it'd be equal to pi radians. So that's where I get that at. Well, the degree marks would cancel there. So I'd have 135 degrees over 180. These are both least divisible by 5. 27. Let's see, 27. And 36. Looks like they're divisible by something else. 3 pi over 4. Now let me verify that, since my basic math seems to be pretty faulty right now. 180, math, inner. Yeah, 3/4. So 3 pi over 4 would be our radian measure. And typically you don't put RAD on there. I put it there just to emphasize it, but we can drop it. And that was number 31, or yeah, 31. Next one you're asking about is number 35. And 35 says convert from degree measure into radian, given the exact values. Okay, that's kind of the same thing, but I'm not sure if you meant one down here. But if degrees is up there, then degrees would be down here, unless I wrote it down wrong. And radians would be up here. And again, I'm looking for some kind of connection. I know 180 degrees is equal to pi radians. So again, the degree marks would cancel. The nice part about dimensional analysis is I don't have to sit there and do a lot of thinking on it. It drives what is this formula right here. Other people are memorizing, well, you multiply it times pi over 180. Simple formula, but why memorize it when the dimensional analysis will drive it? Okay, these both least divisible by 9. So that gives us 5 pi over 20 or pi over 4. Now let me double check that. Yeah, it's pi over 4. I can see that one. And that would be your answer. Let me clear those off. And we'll go over to 10.2. 10.2, number 7. Let's see, this starts on page 748. And we're starting at number 7. What's 7 say? Theta is equal to pi. Find the exact value of the cosine and sine of the given angle. Cosine. Cosine is equal to the, and this is on our unit circle, is equal to the x part. And sine is equal to the y part. So if we go look on our unit circle, over here at pi, this point would be -1, 0. So when it asks, find the exact value of the cosine and sine, then cosine of pi is the x part of our point, which is -1, and sine of pi is going to equal to the y part, which is 0. Now I just sketched the unit circle here, but this is what it's all based upon. Over here is our pi, and this is our x, and this is our y. We're going to be using this in quite a few examples I'll show here. And that was number 7. Okay, let's look at 24. Uh, 24. If cosine of theta is equal to -2/11, with theta in quadrant, what is this, 24? Theta in quadrant 3. So I'm telling you my angle is down here. Then they say, what is sine? Okay, now we could assume it's on the unit circle, but since it doesn't specifically say, use the results developed throughout the section to find a requested value. Since it doesn't say it's on the unit circle, I'm not going to assume that. Now, we had some formulas. Cosine is equal to x over r. And sine theta is equal to y over r. Now, if I look at the given value there, cosine is equal to -2/11. It's in this quadrant down here, and my x values are negative down here, which means that this is my x value, and this is going to be my r value. Now your r, it always has to be positive, so no matter what, I would have put negative up here anyway. But if you have a different problem where you have like tangent of theta is equal to y over x, you'd want to make sure you put the negative in the right spot. Okay, so that's telling us that x is equal to -2 and r is equal to 11. Well, we got our Pythagorean Theorem that says x squared plus y squared is equal to r squared. Now where we're headed is we want to find sine, so we need y and r. Well, r we know, we just need to know what y is now. So we can use the Pythagorean Theorem to help us find that. We'll plug -2 in for x. So I got -2 squared plus y squared is equal to 11 squared. -2 squared is 4 plus y squared is equal to 121. Take the 4 over and it becomes a -4. That seems pretty bizarre. Y squared is equal to 117. So we get y is equal to plus or minus square root of 117. Now let me double check my math. Okay, -2 squared is 4, 11 squared is 121. Minus 4. Okay, I guess it is a bizarre number. Now remember where we're at. We're in quadrant 3, and you have to think what your y values are down there. Your y values are negative, so y is going to equal to a negative square root of 117. So now that we know what y is, we said sine is equal to y over r. So we're going to have negative square root of 117 over r, which we said was 11. And that's our answer for 24. Okay, let me, now if you assumed that was on the unit circle, then you could have approached that from a different standpoint, where you got sine squared plus cosine squared is equal to 1. Let me clear this off, and we'll look at the next one, which is 35. Okay. Number 35, what's it say? Um, 35 is sine theta is equal to square root of 3 over 2. And it says, find all the angles which satisfy the given condition, given equation. Now remember, sine is equal to our y part. Now you might be wondering, well, I thought you said it was y over r. Well, when they give you that this is equal to the square root of 3 over 2, this is one we readily spot as being on a unit circle, which makes it a simpler problem. If I go around my unicircle and I'm looking for my y values, well, I'm looking for a y is equal to square root of 3 over 2. Let me circle this. Square root of 3 over 2 would be right here. Pi over 3 is one of them, because it's square root of 3 over 2. Here's another square root of 3 over 2, so it's 2 pi over 3. Okay, so what we have is we have theta is equal to pi over 3, and we have theta is equal to 2 pi over 3. Let me go ahead and clear those off since I've found those. Now you may think, well, those are your answers then. Nowhere do they say within the range of 0 to 2 pi for my angle. It just says find all of the angles. Well, there's actually an infinite number. We can keep adding 2 pi over and over. Pi over 3 plus 2 pi, which is 7 pi over 3, will give that to us. Pi over 3 plus 4 pi. Because 2 pi goes all the way around your unicircle. Well, we could also do a minus 2 pi. How you can specify this is there's different ways, but you can do a plus and then 2kn, where k is an integer. And I've seen this written different ways in different books, and I'm not sure how this one particularly does it. But for example, if I put 0 in for k, 2 times 0 times n is, or n, let's try that again. It should be pi. Got a lot of sleep last night too. Okay, there we go. So put 0 in for k, 2 times 0 times pi is 0, so we get pi over 3, which is our original angle. If I put 1 in here, 2 times 1 is 2 times pi is 2 pi, which would be this one. If I put 2 in here, 2 times 2 is 4 times pi, which is 4 pi, which is this one. So this accounts for all of our cases. And on this one would be the same way. We have 2 plus 2k pi. K is, again, an integer. Doesn't have to be a positive. It can be a negative. So those would be our answers. And that was 35, so let's look at 45. Sine is equal to negative 2. Solve the equation for t. Now, if we looked at the graph, we would notice something, but I'm going to look at unit circles since that's where the focus is. Sine is your y part. Okay, so 0, 1/2, square root of 2 over 2, square root of 3 over 2, then 1. And then square root of 3 over 2, square root of 2 over 2, 1/2, and then 0. And then negative 1/2, negative square root of 2 over 2, negative square root of 3 over 2, and negative 1. Negative square root of 3 over 2, negative square root of 2 over 2, negative 1/2, and then back to 0. Nowhere does it equal negative 2. It actually doesn't go that high. If you specifically look where sine and cosine are valid, they're valid between negative 1 and positive 1, including those values. So it can never equal a negative 2. So this is a no solution case. And number 56. What's 56 say? It's a triangle. Let me clear off my sheet just to make sure I have enough room. And find a measurement of the missing angle and length of the missing sides. So I got A and 3. This would be theta, C, and then this would be 45 degrees. Okay, now you might think you might have to use a bunch of formulas on this. And on some of these you would. But this one, I know that all the angles add up to 180 degrees inside. and this sharp corner right here is 90 degrees. So if this is 45 degrees, then theta has to be 45 degrees. Now this side is 3, and if this angle is 45 degrees and this angle is 45 degrees, then this side is the same distance as this side, which means that A is equal to 3. Now to find C, I can use a Pythagorean Theorem. So we'd have C squared is equal to A squared plus 3 squared. We just said A is 3, so I got 3 squared plus 3 squared, which is 9 plus 9, which gives us 18. So then we drop our squared. Normally I might put a plus or minus from college algebra, but since we're dealing with distance, you can't have a negative distance there. We're just going to put a positive square root. Now you always simplify your radicals. So 18 is 2 times 2. Wait a minute, I'm lying to you. 2 times 3 times 3. Now we're looking for a pair of somethings. Here's a pair of 3, so that's going to come out in front as a single 3. So we got C is equal to 3 square root of 2. And those would be our answers. Now if this wasn't one of our standard triangles, then we'd have to use our sine is equal to opposite over hypotenuse. And we'd have to use cosine is equal to adjacent over hypotenuse. And tangent is equal to opposite over adjacent. Now that you could use special ones in 55 and 56, but when you get down to here where you got 33 and 48, the only way you can find the angle using the same technique we just did, but to find its missing sides, this requires you to use one of your trig. Now let me show that, even though you didn't ask for it. Let me try to erase that, since I wrote all those formulas down there. There we go. And let's look at, I don't know, 57, I guess. And that's B, and that's A. This is alpha. Although I don't make alphas very good. 33 degrees. And this is 8. Okay. First off, remember the sharp corner here, that's 90 degrees. It's a right triangle. So alpha, all of these have to add up to 180 degrees. So if this is 90, alpha we can get by doing 90 degrees minus 33, the other angle. And, I'm pretty good at my basic math today. That's 57 degrees. Okay, now I'm going to pick some angle to work with. I'll work with this one. Doesn't matter which one you go with. And I want to find this side this time. Now in terms of this angle, this is the opposite side. So in terms of 33 degrees, this is opposite and this is the hypotenuse. So I'd use this formula. Sine theta is equal to opposite over hypotenuse. So we're going to have sine of 33 degrees is equal to opposite, which is B, over hypotenuse, which is 8. Now you multiply both sides by 8, and you get 8 sine of 33 degrees is equal to B. My calculator is already in degrees. You'd want to make sure you're in degrees before you do this. But I got 8 sine of 33. And I'll take it, I don't remember what it said in decimals, but 4.36. Now for, if I wanted to find this other side, this side right here, in terms of the angle I circled, the 33 degrees, this is the adjacent side. So we're going to be working with adjacent and hypotenuse. So this would be cosine theta is equal to adjacent over hypotenuse. So we'll have cosine of 33 degrees. Adjacent is A. over hypotenuse, which is still 8. Multiply both sides by 8. We got 8 cosine 33 degrees is equal to A. So 8 cosine of 33 degrees, 6.71. And those will give us our two sides there. So again, the little trick I did with the previous example only works because it's a 45 degree for your 45 and 45 degrees for your angles for a right triangle. 30 degrees and 60 degrees also has a little bit of a trick, though you could use this technique on any of those, to be honest. Now let me erase that. What was that, 56? Yeah, we showed 56. So I guess we're done with that section, so let's go to 10.3. And in 10.3, our first one is number 15. This is on page 771. And what problem did I say? 15. We got cosecant. Negative 7 pi over 4. And it says find the exact value, state that it's undefined. Well, we're going to add 2 pi. So we got negative 7 pi over 4 plus 2 pi. 2 times 4 is 8. 8 pi minus 7 pi is 1 pi, or pi over 4. Now cosecant, in terms of our unit circle, is 1 over y. So if we go look up pi over 4 in our unit circle, and looking for the y value specifically, pi over 4, our y value, is right here, square root of 2 over 2. So this becomes 1 over square root of 2 over 2. Now we're going to flip the bottom fraction, multiply times the top, so we've got 1 times 2 over square root of 2, which is 2 over square root of 2. Now we'll multiply the top and bottom by the square root of 2. So we got 2 square root of 2, 2 over square root of 2 times square root of 2 over square root of 2, which gives us 2 square root of 2, and square root of 2 times square root of 2 is 2, so those 2's would cancel, and we'll be left with square root of 2. And that's our answer. Number 23. Oops, 23. Got cosecant. Is equal to 25 over 24. Theta in quadrant 1. Now everything in quadrant 1 is positive, so that'll work out well. Pause the recording just for a second. Okay. Now let's see what the instructions say. 23. Use the given information to find exact values of remaining circular functions of theta. Okay, cosecant is equal to 25 over 24. And cosecant is r over y. Now, you may get confused on this, and up here we said it's equal to 1 over y. That's because we're specifically looking it up on the unit circle. Down here, we're not looking up on the unit circle, they're just giving us what the value is equal to. So that's r over y. So we got r is equal to 25. We got y is equal to 24. And the missing value, in order to find the remaining, find the exact values of remaining circular functions. To find the remaining one, I need x. Okay, well, we're going to have our Pythagorean, x squared plus y squared is equal to r squared. So we got x squared plus 24 squared is equal to 25 squared. So we got 24 squared. Pretty sure 25 squared is 625, but let's see. Okay. So this is 576, and this will be 625. Take the 576 over, so I get 625 minus 576. 625 minus 576. It's going to come up nice. That's interesting. So then I get x squared is equal to 49. Square root property, drop the squared, put a plus or minus square root on the other side, and I get x is equal to plus or minus 7. But the problem is, we said it's in quadrant 1 where everything's positive. So x is going to equal positive 7. Okay. Cosine theta is going to equal to x over r, which would be 7 over r, which is 25. Sine is equal to y over r. Y we said was 24 over r, which is 25. Tangent is equal to y over x. Y we said was 24 over x, which we said was 7. Now secant is equal to r over x. R was 25 over x, which is 7. Even though it's given, cosecant is equal to r over y. R is 25 and y is 24. Cotangent is equal to x over y. X was 7 over y, which is 24. You can also use the fact that these are reciprocals of each other. For example, cosine and secant go together. See, I got 7 over 25 and 25 over 7. Sine is 24 over 25 and cosecant is 25 over 24. It's a fraction flipped, reciprocal. And tangent, 24 over 7, and cotangent, 7 over 24. Most people never use these three formulas you saw me write down there. They use the reciprocal properties. But those would be our answers. So let's look at 45. What was that? Okay, that's 23. Yeah, 45 is the next one. What's 45 say? Find all the angles which satisfy the equation. So 45 says cosecant is equal to -1. Now cosecant is, in terms of our unit circle, is equal to 1 over y. Okay, so if we go to a unit circle, 1 over y. Well, 1 over 0 is undefined. 1 over 1/2 gives us 2. No. 1 over 1 is 1. No. Undefined. I get down to here. This y here. I said cosecant is 1 over y. So we'd have 1 over -1, which gives us -1, which is what we're asking about. So at 3 pi over 2, then it's equal to -1. And that's the only places to go around the unit circle. Now I'm going to clear that off. Now remember, it's also there, but we can add 2 pi, and it's also equal to -1 there. I could add 4 pi. I could subtract 2 pi. I could subtract 4 pi, and on, which means I'm going to do a plus 2 k pi, where k is an integer. And that handles all of our places where cosecant is equal to -1. Okay, let's look at 67. Got B, and this is alpha, and I got 12, and this is 34 degrees, and then I got C. I'm guessing this goes back to our sine of our angle is equal to opposite over hypotenuse. Wait a minute. Yeah, it'll go back to that. Okay, and then cosine is equal to adjacent over our hypotenuse, and then tangent is equal to opposite over adjacent. Now I want to pick some angle to work with. Well, the one you best work with is one that's always given. So I'm going to have this one, and then I'll use this side, and I'll use this side. In terms of this angle here, B is the opposite side, and 12 is the adjacent. Well, opposite and adjacent is my tangent. So tangent theta is equal to opposite over adjacent. So I got tangent of 34 degrees equal to opposite, which is B, over adjacent, which is 12. And multiply both sides by 12. And you get B is equal to 12 tangent 34 degrees. Now I'm not going to actually plug that in the calculator. That's kind of the trivial part. This time, I'm still going to work with the same angle down here. Still working with this, but I'm going to be working with this side because it's a known side, and I'll be working with this side. Now this is my adjacent, and this is my hypotenuse. I'm looking for the formula dealing with adjacent and hypotenuse, which is cosine. So we're going to use cosine theta is equal to adjacent over the hypotenuse. So we'll have cosine 34 degrees is equal to adjacent, which is 12, over my hypotenuse, which is C. Now multiply both sides by C, and I get C times cosine of 34 degrees is equal to 12 over C times C, which gives us C times cosine 34 degrees is equal to, those C's cancel, and I got 12. So C is going to equal to 12 divided by cosine of 34 degrees, whatever that gives you when you plug in your calculator. Now, alpha. It's a right triangle, I think, wasn't it? Yeah. Better check that to begin with. None of this applies if it's not a right triangle. Okay. Which means all the angles have to add up to 180 degrees. This is 90 degrees, and the 34 plus alpha has to give you 90. So alpha is equal to 90 degrees minus 34 degrees, which gives you 56 degrees. And that'd be how you get your answers. Okay, let's look at 72. '72 says if let's see, 72. Theta is 87 degrees. And the side adjacent to theta has length 2. Okay, this is theta. Side adjacent is right here. What did I say? Is length 2. So that's length 2. That's adjacent side. Then it says, how long is the side opposite theta? So they're asking about this over here. This is the opposite side. Well, this again goes back to my formulas. The formula dealing with opposite and adjacent is tangent. So tangent theta is equal to opposite over adjacent. They said that theta is 87 degrees, so I'll plug that in. Opposite we don't know. I could put opposite there or just put a variable like x. And adjacent is 2. So I multiply both sides by 2. And I get 2 tangent 87 degrees equal to x. And then whatever that gives you when you plug in your calculator. Let's see, 87. Um, 87. Sine theta over cosine squared theta is equal to secant theta tangent theta. And it says verify the identity. What that means is you start with one side, and that's the only side you can manipulate. Well, it doesn't matter which side you start with. You usually start with the side that looks the hardest to you. So I can start with the left side here. That looks kind of hard. Now I can split that up. So I got sine theta over cosine theta times 1 over cosine theta. That's what cosine squared means. Cosine times cosine. Going backwards, we get this single fraction. Now the reason why I split it up is we got an identity that says sine theta cosine theta is equal to tangent theta. So this I can rewrite as tangent theta. And we also got one that says that 1 over cosine theta is equal to secant theta. And since multiplication is commutative, then this is basically equal to that side, and we're done. So you start with one side, and only working with that one side, you use identities to rewrite it such that it looks like the other side. Okay, let me clear that all off, and we'll go to 10.4. And let's look at number 6. 10.4 is page 794. Let's try it again. 794. There we go. Number 6. Number 6 says cotangent of 9 minus 7 theta is equal to negative cotangent theta of 7 pi over, or 7 theta minus 9. Now this goes back just to the definition. It says for an odd property, or odd identity, or odd property says if you got cotangent of negative an angle, then you can rewrite that as negative cotangent of the angle. So you can take negative and put it on the outside. So if I start with the left side, we can factor out a negative 1, and that would leave us negative 9 plus 7 theta, which then I'm going to have my negative 1, and I can flip these two around, so that's 7 theta minus 9. And by our property, we can take that negative and put it on the outside, so this becomes negative cotangent 7 theta minus 9, which equals our other side. Let's see, number 8. Got secant of 165 degrees. Use the sum and difference identities to find the exact value. You may have need of the quotient, reciprocal, or even odd identities as well. Secant is 1 over cosine, so I'm going to rewrite that. So that's 1 over cosine of 165 degrees. Now I'm going to go my unit circle. And I'm going to try to find two angles added together or subtracted that give me 165 degrees. And I got a very poor choice for a unit circle here because everything's in terms of radians. So let me let me sketch it out. This one would right here would be 30 degrees. This is 45. This is 60. And this is 90. This would be 120, and I see it. 120 degrees plus 45 degrees would give us 165 degrees. So we'll have 1 over cosine of 120 degrees plus 45 degrees. In case you're wondering, it does not matter which angles you pick. Just as long as they either add or subtract, added or subtracted give you 165 degrees. Now I don't got this formula memorized, so let me go up to the use the sum and difference identities. So sum and difference identities. Is that it there? Yeah, sum and difference identities. So we're going to be using the cosine plus. Now from our formulas here, this is alpha and this is beta. So let me go ahead and label it here. This will be alpha and this will be beta. Usually they never give you a secant and cosecant and cotangent because you can always rewrite those in terms of 1 over those values. Now I'm going to write down my formula. So we're looking for the addition. Cosine alpha, and then it's a plus on top, which means we're going to use the sign that's on top here. So we've got cosine alpha, cosine beta. So cosine alpha, cosine beta, minus sine alpha, sine beta. Okay. So this right here becomes 1 over cosine alpha. Alpha we said was 120 degrees. So we've got a cosine of 120 degrees. And then cosine of beta, and beta is 45 degrees, minus sine alpha, which is 120 degrees, and then sine beta, which would be 45 degrees. So just plug in the alpha and beta we identified there. Now if we go look up what cosine of 120 degrees is on our unit circle. Here's 120 degrees. Cosine is our x part, which is negative 1/2. So this will be negative 1/2. Now cosine of 45 degrees. Well, cosine of 45 degrees right here, and my x part is, let me say that specifically. That's 120 degrees, and this is my 45 degrees. So the x part, which is cosine, is square root of 2 over 2. Minus sine of 120 degrees. Sine is our y part, which is square root of 3 over 2. Times sine of 45 degrees. Sine is our y part, which is square root of 2 over 2. Which gives us negative square root of 2 over 4 minus square root of 3 times square root of 2 is square root of 6 over 4. Now they have a common denominator, so let's go ahead and put those together. So we got negative square root of 2 minus square root of 6 over 4. We got a single fraction down below, so we can flip it and multiply times our top part. So that'll be 1 times 4 over negative square root of 2 minus square root of 6, which gives us 4 over negative square root of 2 minus square root of 6. Now put that negative up on top, so we got negative 4 over square root of 2 plus square root of 6. I factor a negative out and then put it up on top. Now some books do not like the the square roots down in the denominator. This is, what is this? Problem number 8. So let's go see what the answer is. Let's see, number 8. They give both answers here. So let me show you how to get rid of that down below. It's not hard. To get rid of the square roots down below, you have to multiply top and bottom by the conjugate of the bottom. Conjugate means the first part's the same, last part's the same, the sign in the middle is different. So that'll be square root of 2 minus square root of 6. Which gives us negative 4 times square root of 2 minus square root of 6. When you're multiplying conjugates together, all you have to do is multiply your first parts and your last parts. Square root of 2 times square root of 2 is 2. Square root of 6 times negative square root of 6 is negative 6, which gives us negative 4 over square root of 2 minus square root of 6 over negative 4. The negative 4's would cancel, and I got a square root of 2 minus square root of 6, and that'd be our answer. Okay, that was number 8. So let me clear that off. Then we'll look at number 22. Number 22, what does it say? Oops, that's 23. 22. If alpha is in quadrant 4, I'm talking about this quadrant here, and the x values here are positive and the y values are negative. I want to keep that in mind. And they tell us cosine alpha is equal to square root of 5 over 5, and sine beta is equal to square root of 10 over 10. Where beta is between pi over 2 and pi. Pi over 2 and pi. This is alpha. Beta would be right here, pi over 2 and pi. So this is beta. And in this one, the x values would be negative, and the y values would be positive. Okay, first off, let's look at the alphas. Remember, cosine is equal to x over r. We need to find the y values here. So we got x is equal to the square root of 5, and r is equal to 5. And we'll use x squared plus y squared is equal to r squared. So we're going to have square root of 5 squared plus y squared is equal to 5 squared. Square root of 5 to the second power gives us 5 plus y squared is equal to 25. And then I got y squared is equal to 20. I take the 5 over. And we get y is equal to plus or minus square root of 20. Or y is equal to plus or minus, that's 2 times 5. So that gives us 2 square root of 5. Now down here we said our y values are negative, which means we're going to use y is equal to negative 2 square root of 5. Now I don't know what we're going to need here. What do they want us to find? Everything. Okay, well I'm going to move this down here to sine beta is equal to square root of 10 over 10. Now that we have that, cosine alpha is given. That's easy. But let me write it down specifically. I also need sine alpha. Sine is going to equal to y over r. Y we said was negative 2 square root of 5 over 5, because r is 5. Now we'll probably need tangent also. So I got tangent theta is equal to y over r. So we're going to have y over x. Let's get that right. So we're going to have negative 2 square root of 5 over x, which was square root of 5. And square root of 5's cancel, and we get tangent is equal to negative 2. Now we need to do the same thing with this sign down here. Okay, sine is equal to y over r. So they're telling us that specifically y is equal to square root of 10. And r is equal to 10. But we need to find out what x is equal to. So we got our x squared plus y squared is equal to r squared. X squared we don't know, plus y squared. So we got square root of 10 squared is equal to 10 squared. So we got x squared plus 10 is equal to 100. We got x squared is equal to 90. Drop the squared, put a plus or minus square root on the other side. And we get x is equal to plus or minus 3 square root of 10. Because 90 is 9 times 10, so I can bring that 9 out as a 3. But we said x is negative in this quadrant. So we're going to have a negative 3 square root of 10. Okay, well, now sine beta is equal to square root of 10 over 10. That's y over r. Cosine beta is going to equal to x over r. X was negative 3 square root of 10 over r, which is 10. And tangent beta is equal to y over x. So we're going to have square root of 10 over x, which is negative 3 square root of 10. Square root of 10's cancel, and I got negative 1/3 for tangent beta. Now I'm not going to go through all these. I'll do the first one. I think you get the idea. Cosine, yeah, we'll look at that one. I think that's the same as the one before. I may do a couple of these. Alpha plus beta. Which, if I look it up in my formula, alpha plus beta for cosine. Here we are. Cosine of alpha plus beta is equal to cosine alpha, cosine beta. So cosine alpha, cosine beta minus sine alpha, sine beta. Well, now we get these values from up above. Cosine alpha, we said was square root of 5 over 5. Square root of 5 over 5. Cosine beta, we just said was negative 3 square root of 10 over 10 minus sine alpha. Sine is negative 2 square root of 5 over 5. 5 over 5. And sine beta, which we just said was square root of 10 over 10. Let's see, that gives us negative 3 square root of 5 times 10 over 50 minus, plus, should say, negative, negative. And that gives us 2 square root of 5 times 10 over 50. Which gives us negative 3 square root of 5 times 10 is 5 times 2 over 50. Plus 2 times square root of 5 times 10, which is 5 times 2 over 50. I can bring those 5's out, so bring that pair of 5's out, and then I got a negative 3 times 5, or negative 15, square root of 2 over 50. And here, bring a pair of 5's out, and I got 2 times 5, or 10, square root of 2 over 50. Now, since they have the same denominator, I can combine together the top parts, and these actually will combine together and give us negative 5 square root of 2 over 50, which simplifies to negative square root of 2 over 10. Now that's the idea behind all of these. Now that you found all these items up here, you just have to plug in the appropriate formula. Let me clear that off and show where the tangent ones. Tangent alpha plus beta. From our formula says that we're going to have tangent alpha plus tangent beta. So tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. Let's go up above and find the values. Tangent alpha was -2. So we'll have -2 plus tangent beta, which we said was -1/3, over 1 minus tangent alpha, which was -2, times tangent beta, which is -1/3. Now this is a mixed number, but I'm going to ignore that for the time being. So -2 minus 1/3 over 1, negative becomes positive, and another negative gives you a negative, and 2 times 1/3 is 2/3. Now to simplify this, this is a complex fraction, fraction inside of a fraction. You multiply everything by the LCM of all your inner denominators. When I say inner denominators, I'm talking about these inside fractions. So 3 and 3, the LCM would be 3. So I'll take 3 times -2 minus 3 times 1/3 over 3 times 1 minus 3 times 2/3. So that's going to give us -6. Those 3's cancel, so I got -1. 3 times 1 is 3. Those 3's cancel, so I got -2. So I got -7 over 1, or -7 is our answer. Like I say, I'm not going to do every one of those. I think you got the idea after those. So last problem. Let's look at number 27. Number 27. Identity. Okay. Sine of pi minus theta. And we want to show that that's equal to sine theta. Again, verifying identities, we start the hardest side, which looks like this. So I'm going to have sine of pi minus theta. Now, I can see that this is my difference property for sine. So if I come up here, find it somewhere, there it is, sine alpha minus beta. Well, this is going to be alpha, and this will be beta. And from my formula, sine of alpha minus beta is sine alpha cosine beta. So sine alpha cosine beta minus cosine alpha sine beta. So this becomes, I just plug in appropriate values, sine alpha, and alpha we said was pi, cosine of beta, and beta we said was theta, minus cosine alpha, alpha we said was pi, times sine beta, which we said was theta. Now if we look up sine theta on our unit circle, not sine theta, sine pi, sine is equal to y. That's our y part. So this is going to be equal to 0 times cosine theta minus cosine of pi. Cosine is our x part, which is -1. So that'd be a -1 times sine theta. 0 times anything drops away. Negative gives us a positive, and +1 times sine theta is
sine theta. And that verifies identity. Again, working with identities, you start with one side and you can only work with one side. And you try to get it to look like the other side. And that was all the problems that were asked to be seen. So I'll go ahead and stop this recording.